Welcome, everybody. This is Eli Sagor with the University of Minnesota. I'm talking to you today from St. Paul. I work closely with Madison Rodman to run the Sustainable Forest Education Cooperative, and we're glad to be here today with the next presentation in our webinar series for this year. We offer this series in collaboration with the University of Minnesota Extension Forestry team and are glad to have you all here. Our presenter today is Chris Beal. Chris is a wildlife biologist with the Superior National Forest. He's one of those lucky people who gets to be based in Grand Marais, at least lucky if you like winter, and cooler by the lake sorts of conditions. I first heard about Chris and this project at last year's excellent meeting of the Minnesota Society of American Foresters and Wildlife Society. Those two organizations gathered in Duluth, and Chris talked early in the project about what he was working toward. And I was really excited to hear about that, as were a number of others, and reached out to Chris to see if he might give us an update 8 or 9 or 10 months later. And here we are. So Chris, thank you for joining us. And I will hand the floor to you.
All right. Thanks, Eli. If there's any issues with my connection or a volume, feel free to interrupt me. So I work for the Superior National Forest, as Eli said, and I'm a wildlife biologist. But my interest in all lands comes out of my wildlife background, quite simply because as a wildlife biologist, I'm interested in managing for wildlife habitat. And wildlife habitat is very much the same as all lands management in that ecologically informed management decisions can't end at boundaries. So all lands management is pretty simply that. It requires collaboration from partners across the landscape. And one of the biggest obstacles, and this has come out in discussions at various meetings, at symposiums that we've had, some of the past forestry and wildlife symposiums that we had talked about this, and they've really identified a need for compiling usable data at the scale of above a project level or above a single ownership inventory layer, but something that's more robust than just looking at national land cover. So this project addresses that, or is an attempt to address it. I'm going to go through and explain the bulk of this project pretty quickly. And I kind of want to give a whole overview of what's involved in it before I take questions. But so if you bear with me and hang in there, we'll give an overview and then I'll take a breather and show you some examples, and we can have a more open Q&A and discussion from that point. So stand inventory. I use our stand inventory layer all the time, as do I'm sure many of you. I'm very comfortable inside my stand inventory. I like this data, I'm familiar with it, but when in all lands context, this is thinking inside the box. And if I have to consider this as a landscape project where the question marks are, it doesn't work well for all lands management. So why is all lands management difficult? Well, I alluded to it. We're comfortable using our own data and processes to describe an existing condition of a forested landscape within ownership boundaries, within our ownership boundaries, whoever R is. We're comfortable evaluating spatially explicit management options and devising treatments. But when it comes to landscapes with multiple ownerships, it gets a lot more difficult. So I say this doesn't work well for all lands management. Well, actually, at this scale, maybe it does. We've got areas that I could probably get myself or a few technicians to go do some inventory at these red question marks, or I can look at imagery, or I could look at pictometry. I've got a lot of options. So actually this is manageable, but what about this scale or even a larger scale? At that point, you need to look for other data sets that are going to at least narrow down your area of interest. So often how we do this is we just take a suite of data sets and we cram it into our ArcMap table of contents, and we do our best to sort through what's relevant and what's not relevant. This is unavoidable, really, to some degree, but it also is really hard visually teasing apart and finding the threads between all these data sets and determining what is relevant and what really is best to inform a management decision. Really, this project aims to take the best of the available data sets and compile it into something that does this sort of kitchen sink approach, but in a more refined, queryable format. So here's the premise. We have a wealth of existing data sets that, taken together, could address our all lands project needs. We could describe the existing condition of the landscape better. We could present a clearer picture of forest restoration needs and identify the areas of highest needs in an all lands context. And we have a lot of data available to us. As I said, stand inventory. We've got a lot of people managing stand inventory, and a lot of it's really pretty good. Additionally, LiDAR-derived canopy structure and vertical structure rasters are incredibly useful for describing the condition of the forest canopy at certain time points. They give us insight into forests that are really hard to get without being on the ground, or even imagery is often not effective in teasing out the parameters of a forest condition this way. And then we have Landsat-derived products like land fire cover and national land cover database information, and a lot of products that have been produced, for instance, by like FIA. And those are really good because they combine a lot of vegetation type definitions in a standardized way. It's universal across the landscape, so that's really useful. However, all of these data have their own issues. So stand inventory. Okay, when was the last time the data was updated? Some of our data is really out of date. If you're looking at a bunch of different inventory data sets, we use a number of different cover type definitions. And then when you're trying to find relationships at a landscape scale, the data is often misaligned and it becomes really difficult to find where the connections are across stands. LiDAR-derived canopy structure, super useful for the vertical profile. It's really not there yet as far as its ability to discriminate between forest types. And forest types are crucial information for us to set a purpose and need and a trajectory for the stand that we want. LiDAR may one day get there, and there's a lot of people working on high-resolution LiDAR and software that can parcelize different cover types. It is not there for most forest types yet. We have to deal with different collects. It's difficult to have that information consolidated in one spot. And then the Landsat issues are, the cover definitions are universal, great. They are often really poor for the sort of veg management that we want to do at the stand level. So the premise again, we are not leveraging all the available data effectively to solve the all lands management problem. We've got a lot of this data can actually inform and improve the weaknesses of the other data if we were to bring it together as best we can. So we want to be able to have a landscape where we have a seamless all land stands layer that tries to bring the best of this information to the surface, but also has these data summarized at the stand level across the entire landscape. So that's what we're moving towards. So here's the parameters. We want to use existing data sets, apply it to all forests regardless of ownership, have it be in a workflow that's updated easily as new data become available, and summarize important information at an appropriate scale. For the purposes of this project, the scale I'm looking at is I want to be more specific in describing the landscape than what the Landsat rasters offer. But I want to be able to get close to what the stand level information tells me. So this project intends to bridge that gap. So this is the design. I use Model Builder and ArcGIS Pro to build a fairly elaborate tool set. It's a library of a bunch of different modules that each run a series of tools for different data set types. And then the output comes in a seamless feature class, but we symbolize that in a bunch of different useful ways. And then we build a connected report table that can have a universal application for a bunch of project needs. So I'll share what these are. So here's the extent of the project, much of Minnesota. The important thing about this project extent is there are a lot of stand inventory data sets that, that people have shared with me and I've been able to use in this area, as well as LiDAR coverage. On the right, I've actually run it previously for Southeast Minnesota and can again. I'm hoping to acquire a few more data sets before I do, but currently I'm really focused on the yellow as the project extent. So here's an overview of the framework. Bunch of geodatabases where I place raw data. That raw data is consolidated using the model modules into a bunch of different intermediate products that are using each other to refine each of the input data sets. And ultimately, there's a surface feature class where stand boundaries are being determined based on the best available data at that particular point. And then from that, we compile, relate, synthesize the information to produce GIS layers and report tables. And crucially, this is a repeatable workflow. So the workflow really is the output, not the ending feature class, because we're constantly getting new and updated data. So we want to use the best of what's available as it becomes available. So here's a screen of what the model builder workflow might look like. This is one module that looks and refines a disturbance layer for use in another part of the model. Crucially, using modules in this way, I don't have to rerun the entire data set from scratch when I get a new data layer. I can just plug in whatever, say I recently just got the new national land cover data coming that's in 2016 as opposed to 2012. So I could just plug that in and run it for a day rather than a full week from scratch. So I kind of alluded to this. There are two types of GIS outputs that are being worked on kind of simultaneously and informing each other. On the top, there's the seamless stand inventory. What's really important about this is how and where are we drawing the boundaries? What are the priority order of inputs? I'm going to share and discuss a little bit more of this later on. And then the same data that is informing, that is being prioritized in the surface layer is also being refined in the ways that we can use this interacting data to improve the inputs. And then ultimately these refined raster data sets that are across the entire landscape will be used to populate the stands that we generate. So stand inventory is supreme in this project. And why is that? Well, this is really aimed at land management. Stand inventory is the preferred management unit. It carries a history of decision making. Obviously, stand inventories are drawn to somewhat an arbitrary degree, but they also encode spatial information that we can't yet model. Someone either looking at imagery or having boots on the ground at some point saying this needs to be considered together. There's so much information that in that decision has been packaged. It's hard to even express in parameters. So I want to maintain as much of that as I can. So this is an overview of the cover that we have in Northeast Minnesota, at least what I've been able to obtain and have folks share with me. I'm sure there's more inventory data out there that I'm hoping in the future can be built in if people want to see how their data can be visualized in a larger landscape context. So as a reminder, how I want to be able to use these data. I'm not taking everything that's in these data sets. I want a generalized, more simplified version of it because I'm looking at a broader scale than just the stand or agency unit. I want to be able to describe the existing condition at the landscape scale. And this is not intended to replace any of these underlying data sets. It's an added benefit. It's for use in concert with the underlying data. And there's an important feature of the data that we're summarizing that allows this to kind of be a bridge from the landscape scale to the stand inventory scale. So the data that I want to capture that's most important, the stand boundary, is the spatial drawing is actually really important for reasons I discussed. General cover type of the primary dominant tree, the year of origin, if I can get it, the inventory data source, if possible, the year reviewed so that we can know what data is more recent, what data may be in the large output table. If you have a stand that hasn't been reviewed since 1982, and there's a lot of newer information that's been populated from other sources, well, maybe you lower how much you value the stand inventory data at that point. And then this is the bridge. As much as possible, the original unique stand ID is maintained, and the boundaries, the spatial extent of that stand are maintained intact through all these processes. This means that you can do queries across all these data sets, but then you can link through a join, you could link it back to your original stand IDs and look at the attachments in your own native format that you prefer. So to plug in all the stand inventory data sets, each gets its own module, and these shared field definitions are populated, which is great. Now we have kind of a universal table. And then you create a feature class off this table from the inventory data, and okay, misalignment. And this is where a series of generalization steps start to alter the underlying data a little bit for it to be seamless. So one of the model steps has to go through and identify gaps that aren't too large, but are need to be filled. They're adjacency gaps. And so it'll do that, and it will draw generalized stand boundaries. You can see the stand boundaries have been changed a little bit, but now you can query and understand adjacency and run patch analysis and see where the edges roughly are more realistically. So here's an example of how that might look. In the tan, we have a bunch of misaligned data sets. And in the white, you have the all lands generalized output. And you can see the data is being moved a little bit. You've got little tracers of detail here that aren't being captured. But the threshold for moving these points is very, very small. And especially at the landscape scale, it's not important at all. And the result is cleaner and way more usable. You don't want a million fragments in your stand inventory layer, even if it is a coarse all lands one. So again, all these stray parts, and they get refined to centralized boundaries. So what are some of the generalization steps? All of the processing is done. Everything gets converted into 10-meter grid rasters. I found that the 10 by 10 meter grid is a very nice size because it does capture quite a lot of fairly fine detail as far as the polygon shapes and whatnot without completely setting my computer on fire. Trial and error has led to me to eliminate features that are less than an acre in size. That seems very small to people, but it's easy to do a series of dissolves or selects to scale up your selection, to scale up your stands if you want broader clumps of forest types and age and disturbance and whatever. So I want to capture some of that detail, but less than an acre, and it just becomes too many parcels out there. Polygon edges get simplified as was shown, and the gaps between adjacent inventory data sets up to 100 meters in some cases, but usually not that many get closed. So now this is the priority of outside of once we get beyond the stand inventory data, what are the other tools in our toolbox that we have to draw pretty good cover boundaries? So National Wetlands Inventory is an excellent source, and that fills out a lot of the gaps there. We have products that have looked at disturbance in the past, especially Jody Vogler's product that was just made available to us in this summer. It is really excellent. We also have the resource assessments look at disturbance across the landscapes, and that gives us a year of origin for much of the landscape where we haven't inventoried on the ground, but it's useful information to be able to capture and query. And the disturbance, along with some more coarse basic definitions on landscape, creates some pretty good cover polygons. And then National Land Cover Database and transportation layers are really good sources that you can be confident in their ability to pick up developed landscapes, agriculture, and barren, which we want in really general terms. If we're wanting to look at forest edges, what is the adjacency? What are the cutoffs look like? So this is pretty good. This forms the basis of a lot of the cover polygons in this order. And then we have the white space left on the map. We've got the gaps. So we go to the place of last resort to generate something that's going to approximate a stand. I forgot to mention ownership data is generalized, and text parcel information is used just to align boundaries. It cleans up the data and makes it more usable. So that's applied throughout. So the leftovers, using state LiDAR-derived canopy metrics. These are from the 2006 to 2012 collects. 20-meter grid metrics are the ones I'm using that were produced by Mike Falkowski, the Nature Conservancy, who has been extremely instrumental in helping get this project going and providing feedback and providing direct support for it. Produced some layers that, using fusion and similar canopy thresholds. So from this, we can do our best to draw the remainder of the boundaries. So just like what's happening throughout the model, you're leveraging other data sets to refine these rasters. So this is a canopy height look, and in yellow, we've got some really tall trees identified there, but that's not a line of poplar trees. That is power lines. So we can, in the model, remove a lot of that misinformation. And then once the data sets are refined, we can look at islands essentially within the information using the canopy surface, either big changes in heights or big changes in surface roughness, to draw forest canopy changes that often capture some sort of change in forest type or some sort of change in age. So you can see in the top, this is the raw data, and a series of algorithms has boiled down that data into some drop-offs that are then used along with ownership boundaries to create some inventory parcels. So again, we've got the seamless stand inventory that we've now built and completed on the top. And then we've got the refined GIS rasters that serve as an information source to fill and populate all these stand layers. So we populate the seamless stand inventory with number 2. And now we have all these relationships in a queryable, relatable scheme. We can look at ownership across everywhere, or generalized ownership. We can look at age class distribution. We can either tell our query to look exclusively at what's been determined with stand inventory, or we can report on age class that includes inventory and also disturbance year, so that we've got a wider net of possible year of origins. We've got a ton of different cover metrics. We've got the original individual stand inventory cover where it exists reported. We've got a series of crosswalks that kind of scale that up to more generalized terms. And then we can repopulate all of these stands with landscape scale metrics from Landsat-derived products like the National Land Cover Database or all the land fire cover types. We can report on disturbance. This one's shown in 5-year increments. We can report on potential native plant communities, UMD project that has been pretty useful and is another good source of information to use in these stands. And then you've got a bunch of LiDAR canopy metrics from the 2006 to 2012 collect summarized to give you that snapshot of what the forest looked like at that time. So here's reporting on max canopy heights. Here's reporting on mean canopy heights. You've got percent tree cover. You've got measures of rugosity and roughness. and understory, overstory, different strata. And one thing to note is that in this compiled database, there are fields in every spot that indicate where the source of this data is, and in the case of the LiDAR, what collect was made. So if you want to compare across the state, you can, but you also need to understand that your margin of errors are increasing because some of it was collected in 2007, others in 2011. So you can actually filter out, if you want to just look at one at a time, you could filter time of year, you could filter the year that the collect was done. So you can kind of go between those looks for whatever your purpose is. So that was a rundown of the project. Essentially, I'm going to show an example in the all lands feature class that we have right now. I'm going to show some report tables and I'll get to my conclusion. But if anyone has any comments or questions at this time, before I get to kind of the application part of it, I would take some.
Great, thank you, Chris. As a reminder, and maybe it's not a reminder because I realized as soon as I muted myself, I forgot to mention this, but the best way to share questions is through the chat pod. You can access that either from the green tab at the top of your screen or from the controls at the bottom of your screen. Look for chat, and then you can just go ahead and type your question in. Chris, I'm not seeing any questions at this time, so maybe we'll wait just a moment, but I think it's going to be safe for you to move along and continue your presentation momentarily. And so why don't we just have you go ahead and do that. I will remind folks again, please don't wait for him to pause. If you have questions, you can share those at any time. And Chris, it looks like you've moved to a live screen share. That's perfect. We are seeing your screen move around and so on. So you're off.
All right. So this is a look at the last draft that was produced. This one's actually a little old. I'm in the process of updating it with new data sets and some new metrics. This one was produced at 20-meter grid size, so there's a little more roughness to it. But I've got I've got stands across much of Minnesota in this product here, and you can look at how a lot of this information is summarized. So captured within it are generalized ownership, the native plant community province and subsection, the LiDAR collect here, whether if there's a block of information that summarizes the underlying inventory data set, if it exists, disturbance, a bunch of different definitions, and then a bunch of canopy metrics from LiDAR. So perhaps you're interested, let's say you're interested in what has been called you're interested in we're going to say only in Northeast Minnesota stands, but you want to know what inventory and a crosswalk has called dominant paper birch. Where are those locations? So a minute while it populates. Okay, so I'm going to be interested in paper birch. I want to try and find stands in the landscape in this area that I think might be declining, that are mature stands, but they don't have a lot of tree cover. So this field here that was populated, LiDAR looked and said, what is the percent of this stand that's over 12 meters? And there's definitions spelled out for all these different variables. So I'm going to say, where are the areas that are less than 50% tree cover that have been called paper birch? Because I'm looking for older stands, and I run a query. Okay, well, I've got a pool now of stands that I may want to look at further. So I look across the landscape and I come to this and I'm like, oh wait, that's not what I'm looking for. This looks like it was harvested in the last few years. Okay, well, I want to exclude those. So I'll go find the disturbance year information. And I'll say, I don't want disturbance since at least 2000. So let's hope that excludes that, because I'm interested in stands that had paper birch or were called paper birch at one time, but seemed to be not well stocked with paper birch trees. Okay, well, there we go. That's remove that. And that's just an example of the sort of relational power that this has. There's we can fill this, these polygons are just bins to fill information. We could fill it with anything that's going to be usable. Another aspect of having this all in a single table isn't just the spatial information, it's the tabular information. And I'll switch to this. So for the Forest Service, I've built a lot of these dynamic tables that move from that are basically plugged right into some sort of spatial output. But since it's a reliable way, you can create dynamic report tables. And this could be really useful as a first look of describing your project. If you're you want to look at a collaborative, or you want to report on a county, you want to report on the state of the data. So this is a simple draft of what I'm designing. Generally, on the left, you'll have a bunch of toggles that are kind of master switches that query the whole data across the entire spreadsheet. But you'll have automatic reports. So I can report on counties. So right now I got these 4 loaded. So I'll report on St. Louis and all ownerships. And then here's the updated age class distribution. Everything's labeled. So we got 1.5 million acres in St. Louis County of all cover types that have been inventoried, and we have an age class distribution. Maybe I just want to look at the aspen dominant types. Well, that information is provided. So here's a look at the age class distribution of aspen. Or maybe I'm interested in not all ownerships. I want to see what federal looks like. So here's a look at aspen in St. Louis County on federal. And you could see, if you're coming up with a purpose and need in a project area, or trying to express as a first look, the condition of a landscape, this could be really useful in project planning across all ownerships. So here we've got a report on the dominant cover type percentage by within St. Louis County on federal ownership. So maybe we just want to report on Cook. Okay, well, it's ready to be reported on. And you have standard definitions that you can use everywhere. So we could add project boundaries that you could switch through to and just report on project boundaries. You could report on ecological provinces or subsections. You could report on watersheds, whatever the need would be. Another example is perhaps you want to look at Cook County. You're looking at all ownerships, and we've selected sugar maple. We've got a list of stands here. We want to know where the sugar maple, northern hardwood, crosswalk types are, what ownerships they're under. We're in Cook County, 69% in federal, according to this compiled data set. So this is an early version of this. There's a few categories that I hope to report on. Not only reporting on just basic veg classifications and canopy structure as it was whenever the LiDAR was taken, but reporting on percent landscape disturbed and queryable for any ownership or area. Also, this is a good way to report on the state of the data. You could look at an area and see how much is inventoried. You could report on the ages, the times since inventory. There's a lot of just added touch information that this could be compiled, and we could all land managers, forest managers that work in an all land scale could benefit from a kind of a shared report tool like this. All right.
Hey, Chris.
Yeah.
It appears your screen isn't updating for us. Maybe if you could move your cursor around a second and we can see, we might not have seen some of that last stuff you were showing us.
Oh, I'm sorry. Thank you. I did not switch it. I should have switched it. Yeah, apologies, everyone. I'm new to this format. Here we go. Yeah, I guess that last little section probably didn't make a lot of sense. Thanks for chiming in. Can everyone see the spreadsheet?
Yes.
Yeah. So I'll go over it again. I think I've got time. Again, apologies. So we're going to populate. This is a dynamic report tool that takes the tabular information that's been compiled and reports it out, carves it up in any way that you want, that we can build into it. So you can report by counties. These are the 4 I've got loaded, or ownerships. So I've got an age class distribution. Maybe I want to report on Lake County. And I want to report on, let's see, state. So you've got dynamic tables that will report on this information any way you'd like to. I'm reporting on Aspen right now, but I could select off any of them. Maybe I want to just report on all forests. So distribution, Lake County, on all ownerships. And this up here in the top left is kind of a universal switch that allows you to carve up the data in ways that are relevant to you. There's another example of a report. Dominant cover type, we're looking at Lake County by state ownership. So these are the percent cover types in this area. Maybe you want to see what's on tribal. So Lake County tribal. No tribal in Lake County. So let's go to Cook. And you can see how this would be useful to have this information automatically populated and dynamic for any query that you want. Here's another example. Maybe you want to know where Tamarack is in all ownerships, and we're again in Cook County. So what ownership is Tamarack? Well, that's Aspen there, because that one's populated correctly. So you've got 70% of the boundary waters, 48% in federal, tribal, state, what have you. So, and I was saying, I imagine this tool reporting not just on the data that's in there, it's going to report on the state of the data. So it can report on how old the data is, areas have been inventoried, what percent of ownerships need inventory. And this could be a good collaboration tool to kind of quickly and effectively summarize this information and however people see fit. Okay, so where am I? Okay, so concluding. So the strengths of this approach. Can everyone see my PowerPoint? Someone chime in?
Yes.
Excellent. So the strengths of this report, this tool set has an adaptive framework. We revise and adjust as necessary. We rerun as updated data become available. We incorporate new data sets and useful metrics. And the product gets better as the underlying data sets are improved, which is really pretty powerful. This doesn't divert from any other ongoing initiatives. This is a compilation. This is a consolidation. It only benefits as people go and find better ways to express and summarize our GIS data in all sorts of ways. And this is the start of a way to organize and combine data sets from multiple stakeholders. So the weaknesses, this really is a workflow that's envisioned as not having an endpoint because the data that goes into it is of a varying quality and vintage. So it has an indeterminate end product. I see this as being run every 6 months, and you'll point to a version maybe that you used to do your project planning or reporting, but it's not anytime going to be concluded as a standalone layer. That's not really the ambition of this project. It doesn't solve issues with underlying data sets. It's crucial. It needs to be used with care. It compiles data intended for use at different scales, representing different years and of varying reliability. It really is trying to use the best of what we've got. And in some cases, the best of what we got isn't very good. So you can either use that or you can toss it out in your queries. But understanding that's going to be really important. This is the best available approach. Some of the stuff we have is great. Other is, it's the best of what we got, and hopefully we'll fill those gaps in the future. It's also for use at an appropriate scale. As I said, it bridges the gap between the large scale course data sets and ownership specific site data. So given the complexity and the asterisks involved with this project, I don't see this being made freely available to the public. It isn't that data set. But I do see this as a something that can serve a lot of us who are in land management and are in collaboratives, and anyone that's looking at forest inventory beyond their boundaries. This could be a really important tool as long as they understand the strengths and the limitations. So currently, what we're doing, I've got a very drafty draft that I'm working on revising on our Forest Service AG ArcGIS Online account. The Forest Service won't serve this data publicly. A lot of it isn't owned by us. It's compiled by us. So access is available to those with Forest Service partner accounts. Who can get a partner account? Well, I think many of you might. You can email me to request one if you've got some sort of landscape project or involvement in some way. You know, if you're a land management agency partner, state, county, tribal, if you're a collaborator from the TNC or the Minnesota Forest Resource Council or university researcher or adjacent to that, and many of you will be. If you're a collaborative stakeholder, like a Manitou Collaborative, North Shore Collaborative, a Future Collaborative, this could serve as a good project planning and monitoring tool. So again, my email address is christopher.b.beal@usda.gov. And we can definitely get you hooked up with some of this information. So what would I consider successful outcomes for vegetation management that this tool helps facilitate? I think this could really help improve our description of the existing condition of the forested landscape with better quantitative description and detail. I think this will help facilitate communication among different agencies and stakeholders. You'll be able to see kind of the relevant information that's unified across the landscape and be able to identify too where the gaps are. I think at an appropriate scale, this is a potentially really powerful tool for more efficient analysis of landscape for Minnesota forest managers and people interested in habitat. I think this could help report on what data is out there and where the gaps exist. I think this provides an incentive for updating our spatial stand inventory data. This only benefits from the improvement of the underlying data sources, and this hopefully will incentivize, not only does your local data improve, but as this develops and becomes a stronger resource, this data improves and the two strengthen each other. So there's opportunities for funding, because if you help yourself, you'll help the larger landscape report as well. And also there's the incentive to acquire more up-to-date and higher resolution LiDAR, which is the most powerful non-inventory way that we have. And it's separate from inventory. The two are the two report on two different forest parameters and are both extremely important and are very powerful when they're conjoined. They're powerful separate. They're even more powerful when they're used together to inform each other. So currently I'm working on wrapping up this latest run. I've added new data sets. I've got some updated data sets, some new algorithms. I'm looking at some of the LiDAR pilot projects and hoping to incorporate some of that stand generation into the new version. Better AGOL functionality is my number one priority since partners are starting to come in to look at it. It needs to work a little better than it does currently. Expanding the report tables as I discussed, and then a better user documentation. So I'm working hard the next several weeks and month to kind of wrap up this version of it. So acknowledgements, the Nature Conservancy, Mark White, Jim Manolis, and Andrea Brandon, they have been instrumental in helping this project get done. They've provided feedback, they've provided direct assistance, they've provided some of the data that's been used in this, and they have been instrumental in helping move this along. Additionally, Mark Nelson with Forest Inventory and Analysis and George Host at NRRI, they've provided feedback and are working with me to develop some other applications related to their data sets that might help the project be more useful. And then local staff, Connie Cummins, James McFarland, Susan Catton, Eric Adula, and Mike Cruteau have all been very supportive of time spent working on this and have helped with various aspects of it, to which I'm very grateful. And everybody out there that's working on managing and reporting and putting together data to report on our forest landscape. Like this is only a testament to how many dedicated people, both in the GIS realm and the silviculture and forestry realm and the wildlife realm, are working on creating excellent products at various scales. So this couldn't be done if Minnesota didn't have such robust data sharing and data projects in the works. All right. Well, thank you, everyone.
Chris, thank you. That was just a terrific presentation, really an impressive project that you're working on, and I appreciate your sharing it. I have a couple of questions, 3 questions so far. One from the Cloquet Forestry Center, and to some degree you've answered this since it came in a little while ago, but not all of it. Who is your intended audience for these products, and how will you make them available? You've to some degree, you've discussed that. What risks? Well, hang on.
Okay.
Hang on, I'm not done yet. So what risks did you consider as you were compiling data? And are there risks to making these data available? Go ahead.
Yes. That is, I mean, I addressed it. The audience is really the users that would be partners in landscape management, which is why until this is going to be in software terms in beta as we work to tease out what's useful and what is misleading. There's still a lot to sort through. This really kind of provides a platform to look at everything all at once. And if we find that some data is just not useful, people have different needs. So what may not be useful for maybe too coarse for one utility may be just what another person needs. So it's a lot of information is kept there, and will take some discrimination. And again, that's why this is going to be made available to forest management and related professionals.
Another question: have you tried incorporating invasive species data?
No, that's a great question. Once you've parcelized the landscape, you can fill those parcels with any data that you want to report on that summarized at a stand unit level. So invasive species, there's all sorts of ways that you can report on. You can report on percent of stand covered by specific species of interest. You could look at a bunch of different parameters. And indeed, if you've got a specific utility for this, email me and we can discuss how this might work with your particular data set.
Great. Last question that I've got so far, Chris. You mentioned that some data are more reliable than others because of just the nature of the data, inventory age, all sorts of different things. How can a user of this map evaluate how reliable a particular output might be? Maybe it's on a particular spatial scale. Are there sort of error indicators in there, or how can a user know how reliable a particular output might be?
So that's a really excellent and difficult question. So the premise here is you use the best of the data available wherever it occurs. The way that so far I've tried to capture what data is the best and what data is not the best is providing metadata right in the field so you can query on it. When was the stand inventory conducted? If it's you can look right there and toss out anything that's older than a certain time. Again, this represents a ton of different efforts and efforts that have their own rule sets, efforts that have their own quality control. There are different levels of funding. It is a best of what we got. So all the metadata about where both the inventory sources as well as the source of the lidar data, when it was flown, the source of the disturbance data, that's all captured in there. But it's up to the user to say, okay, that just is really too coarse for my purposes or too out of date. They can make that determination in their queries.
Great. Thanks, Chris. Another question just came in, and I'm not sure I understand the latter part here, but maybe it'll be clear. I think you'll get the idea. Does the model and software support querying by proximity? For example, does it show incidents of stands with a given composition that are situated within a ½ kilometer of marsh, it says, or seasonal water features?
Yeah, heck yeah. It's a GIS layer. So it's an inventory layer. So you can put it in, clip it to whatever project area that you would need to use. And again, if you're a partner, you're working towards some sort of collaborative all lands project with this data. But it's just a GIS feature class. So you can use anything in GIS that you would use to establish relationships.
Great. All right, I'm not seeing any other questions. Madison has just posted a couple of links to the chat pod. If you would like to request continuing education credits, the link is there. To provide feedback on the webinar, you'll also see the link there in the chat pod. Chris, I want to thank you again. This was an exciting project when you first discussed it, when I first heard you discuss it, as I said, just under a year ago, Duluth, and I appreciate your willingness to share it with us again. As a reminder to those of you who are watching, we have been recording this webinar. We'll make the recording available on our website sometime in the next couple of days. But Chris, thank you again for your time and for sharing this work with us, and for what I'm sure must be a huge amount of work to develop what looks like a useful tool for many across the profession. So we appreciate it and appreciate your joining us today.
Thank you.
All right, we're signing off. Again, a reminder that our next webinar is December 17th. That'll be John Steigerwalt talking about ruffed grouse. We'd love to have you join us. Bye-bye.